Hello class, this is your final exam review. On problem number 1, you are asked to identify the domain, give the domain and range of this relation as an interval. So let's look at what the answer is. So right here, our domain are the x-coordinates of this relation, all the x-coordinates of this relation. So that would be all of the values between -4 and +6. So this is the domain of this relation. The range of this relation is all of the y values on this relation. So that would be all of the y values greater than -5 but less than +1. So our answer is -5 to +1. Now, again, this interval has, our answer needs to be written in an interval, and it does need to be written with brackets because we at those endpoints, we are including those endpoints. So here, 6 is part of the interval, and so is -4, just like -5 and 1. Moving on to the second problem, you're asked here to write the equation in terms of x, which means to solve the equation for y. So we want to know what y is going to equal to here. So on this equation, we'll start by subtracting 8x squared from both sides. And 4y squared equals -8x squared. They make these pens a little bit thinner. And 12 minus 8x squared. We'll divide everything by 4. And y squared equals 3 minus 2x squared. We then take the square roots to both sides, and y equals to both the positive and negative square root of 3 minus 2x squared. So there's your second solution, your solution to problem number 2. Now for problem number 3, we want to evaluate this function given that f of x is equal to -5x plus 12. We want to find f of 4a minus 7. So what that means is that we are going to replace this x with 4a minus 7. And that would give us that f of 4a minus 7 is -5 times 4a minus 7 plus 12. So distributing the 5, we end up with -20 plus 35 plus 12, and simplifying that, we get the following. Get that f of x equals -20a plus 47. And there's your answer. So, and it's not f of x, I'm sorry. It is f of 4a minus 7. This is our answer. Now to find the zeros of a function, we simply need to get our function, which would be this, and set that equal to 0. So we have x squared minus 10x, that should be 10x, plus 9. So the way we figure out what makes this equal to 0, we have two options. We can try factorization, or we can use the quadratic formula. In this situation, we can do it by factorization. The quadratic formula is not necessary. And now the factors of 9 that add up to -10 are -1, times negative 9. Those two factors add up to negative 10. So if this is the factorization of x squared minus 10x plus 9, and we want to know what makes that equal to 0, well, those would be the opposite values. X would have to equal to positive 1 to make this equal to 0, and to make x minus 9 equal to 0, x would have to equal to positive 9. Positive 1, I meant to say positive 1, not positive. Positive 1 and positive 9. So there's our solution. X equals to positive 1 and positive 9. Those are the zeros. Let's now look at our next example. In this example here, we're going to identify the interval in which the function is decreasing. Well, the graph is decreasing in this section here. Okay, from this turning point in blue to this turning point right here in red. So that's that green section there. Now we're only interested in determining again from what x value to the next x value. So that's in this section here. Let me do it in orange. That's in that section there, which the x values are positive 2 to 4. So that's our interval. This function decreases in the interval of 2 to 4. Okay. So again, this is not an ordered pair. This is again saying from 2 to 4, and we write it like that. And we do not use the brackets, we use the parentheses, because at those locations it's changing direction, so it's neither going up nor down. It's standing still in that direction, but they can starts to go down as soon as I start moving away from 2, and it stops going down as soon as I get to 4. So that's why we don't use the brackets, we use the open interval notation. Now, on the next problem, on number 6, if f is an even function and f of negative 3 is 12, what is f of 3? Remember, this notation means that we have the coordinate negative 3, 12. And I'm going to draw this to scale, but let's say 12 is here. So we have this point right there. This is f of negative 3, that point right here in black. Well, if our function is even, that means it's symmetrical about the y-axis. So something that's even means that it's symmetrical about the y-axis, and something that's symmetrical about the y-axis means that the graph is even. Those things, again, it's a biconditional statement. So what that means is that there's going to be a point on the other side that's going to have the exact same y value that is equal distance to this, again, vertical line, to this mirror image. So for example, this might not be the correct graph, but let's say that a graph would be something like this, like a parabola. This is an example of an even function. So if f of negative 3 has a y value of 12, then that means at f of positive 3, that's also going to have a y value of 12. So that's our answer. F of 3 is also going to equal to 12 because of the symmetry that it's going to have. Now for number 7, we want to describe the transformation of this function. Well, let's start with the negative sign. The negative sign is a reflection over the x-axis. That is a vertical reflection. The negative 4 hold on, let me change my pen color, the sizes again. Okay, so for number 4 is going to shift the graph 4 units to the right, not to the left, but to the opposite side, to the right. And then 2, that's going to shift the graph for 2 units, not 4, the number's 2, 2 units upwards. So 2 upwards, 4 units to the right, and a reflection over the x-axis. Now, if f of x, now problem number 8 is similar to problem number 4, where you're evaluating one function to another. So this notation here means that we're going to compose our function and plug in function g into function f. So I want to get this value for g and plug it into the x of f. So we're going to end up with 2 times 6 minus x squared plus 1. So you see I replaced this x here with 6 minus x squared. I continue by distributing the 2. We end up with 12 minus 2x squared plus 1. And now combining the following two terms, these two terms here are like terms, we end up with a negative 2x squared plus 13. So here is your solution to problem number 8. And let's find the inverse function to problem number 9. Well, to find the inverse function, we'll start by replacing the x with the y. Remember, this is the same thing as y, so we'll switch the letters. X equals 2 y to the third plus 4. And let me put the x on this side instead. So 2y to the third plus 4 equals x. And we solve the equation for y. So I subtract 4 from both sides. I divide everything by 2. I could just divide all of that by 2. Let me just write it like that. Divide all of this by 2. So y to the third equals x over 4. I'm sorry, x minus 4 divided by 2. And to get rid of the power of 3, we're going to use the root, but the third root this time. So we end up that y is equal to the third root of x minus 4 over 2. And that's our inverse. Now the notation should be f inverse, f to the negative power, so f inverse of x. That equals to the third root of x minus 4 divided by 2. So here is our solution. Now to identify the vertex of a quadratic, we need to do two things. We need to figure out again the x coordinate and the y coordinate of the vertex. So to find the x coordinate of the vertex, we use negative b divided by 2a, where a, b, and c are 4, 24, and negative 15. So replacing b with 24, we end up with negative 24. 2 times the value of a, which is 4, gives us negative 24 divided by 8, which is negative 3. Now what we do from here is that we're going to plug in this value. Since now we know what the x value is, we figure out the y value by plugging it in. Because remember, f of x is the same thing as y. So y equals 4x squared plus 24x minus 15. And we know that x is negative 3. And then just simply typing this into our calculator, we're going to end up with a total of negative 51. So that's your y value. So the vertex is negative 3, negative 51. Let's move on to the next example. Let's determine the end behavior of the polynomial function. Well, to do that, we're going to use this here. You need to remember this part right here. So we use, again, the leading coefficient test. So this is the leading coefficient. And what we need to recall about the leading coefficient test is that whenever, here it is, right here, whenever this number here is an even value, okay, is an even value, the graph is going to create, again, something that's symmetrical through the y-axis. And there's two possibilities. The end behaviors, in order to be symmetrical through the y-axis, means that it's going to have the two ends either point upwards or the two ends point downwards, again, like a parabola. Okay, that's the most basic even function that exists. Which is what we have right there. Okay, if it's an odd function, well, one end opens downwards and the other ends open up, or it's reversed. The left end opens upwards and the right end opens down. But in this situation, because it's an even number, then obviously it's going to be one of these two choices right there. Now, to determine if it's opening up or down, we then use, again, that leading coefficient. And in this situation, since that number is negative, the two ends of this polynomial are going to face downwards. If it was positive, it would face up. So here, being negative is going to be this. So that means that as x approaches the left side, negative infinity, the function values are decreasing unbounded. So they're going to approach negative infinity as well. And as x approaches positive infinity, well, again, the right end is also pointing downward, so it's also decreasing without bound. So it's also approaching negative infinity. So that's how we describe, again, the end behaviors of this function. Moving on to problem number 12, where we're asked to divide these two polynomials. We're going to use synthetic division to divide this. So I start by getting the opposite of this number, so -1, and I divide it by that number there. So -1/2. I have my inverted division box, and I just simply write the coefficients of my dividend. So 2, -13, +9, and 8. And synthetic division starts by bringing down the 2. And remember, from there, we multiply this value with this, which is going to become -1. And we add the two quantities together. So -14. Doing the same thing, repeating the step, multiplying these two, we end up with 7. And adding them together is 16. Multiplying 16 and -1/2, that's -8. And adding that with 8 gives us 0. So the last value, we recall, that is our remainder. So our remainder is 0. Now, since we had to divide this value by 2, we have to do the same thing with our quotient here. So we have to divide these values by 2, and that's going to give us our answer. So we're going to end up with 1x to the second power, 1 degree less than what we start off with, minus 7x to the first plus 8. So this is our quotient. And since there is no remainder, well, we don't add anything extra there. So there you have it. Now, to find the zeros of the function, of this function right here, remember again, that simply means that we're going to get this set equal to 0. So the only way that this equals to 0 is if the factors equal to 0 themselves. So starting with the first one, x equals to 0. (2x plus 3) equals to 0, and x minus 4, that is also equal to 0. So our solutions are 0, negative 3 over 2 when I solve this equation. Subtract 3, divide by 2, and positive 4. So these are the zeros to this function. Now, number 14, I want to know what I want you to describe the multiplicity of the 0 at x is equal to 1. Well, here is 1. Now, the multiplicity at 1 is going to be an odd value. This multiplicity is odd, and the reason I know it's odd because it intersects the x-axis. It goes through the x-axis and crosses, just like here at negative 2. So the multiplicity at these two values are both odd, meaning that x equals 1 an odd number of times. X can equal to 1 one time, 3 times, 5 times, okay, 7 times, and so on. But it's going to equal to the value of 1 an odd number of times. In order for a multiplicity to be even, the effect on the graph, like here at 3, it touches the graph but doesn't intersect. It simply touches and moves in the opposite direction. So this has an even multiplicity. So the multiplicity at 1, our answer right here is that the multiplicity at x equals 1 is odd. So that is your answer. All right, let's move on to the next example. To find the zeros in this function here, well, we have to use the rational zero test and identify what the rational zeros are. And then again, using trial and error, use synthetic division, see which ones we can find, and see what that leads us up to. So to find the rational zeros, we're going to get the factors of 6, the last number here, which are positive 1, 2, 3, and 6, and divide them by the factors of 4, which are 1, 2, and 4. So our list becomes all of these numbers all divided by 1. That's going to keep the list the same. So 1, 2, 3, and 6. Now dividing all those same numbers now by 2. That's 1/2. 2, which is already on the list. 2 divided by 2, that's 1, which is already on the list. 3 divided by 2. And now 6 divided by 2, which is 3, which is already on the list. And now we divide all of those numbers by 4. So 1 divided by 4 is 1 over 4. 2 divided by 4 is half, which is already on the list. 3 divided by 4 and 6 divided by 4, which reduces to 3 over 2, which is already on the list. So this is the list of possible rational zeros. So from this list, we're going to use again trial and error to determine what could possibly be 1. And let's see, let's try 1/2. Let's try the number 1/2. So 4, 12, negative 19, and 6. Let's see if 1/2 is a 0 to this. According to the remainder theorem, or the factor theorem, if we use the remainder theorem and synthetically substitute this in and get a 0 at the end, meaning that there's no remainder, then half is going to be a factor. So let's see, let's bring down the 4, multiply, that's 2. This adds up to 14. Half of 14 is 7. That adds up to negative 12, and half of negative 12 is 6, negative 6, which adds up to 0. So there we have it. X equals to 1/2. So let me highlight that. So 1/2. So x is going to equal to 1/2. Now to find the remaining zeros, we're now going to get to this function here, the quotient, and set that equal to 0. Well, one of the things you can see here is that every single one of these numbers is divisible by 2. So let's do that. Let's divide everything by 2, just so we can reduce this value. And we end up with 2x squared plus 7x minus 6 is equal to 0. Even the 0 gets divided by 2. Remember, we did to one side of the equation, you have to do to the other. Now, we can try factorization, but I don't see any factors of negative 12, that can give me 7. Because I need a negative 12, I need a negative 4 and a positive 3, but that adds up to negative 1 and not 7. I need these to be a different sign. So there is no factorization here. So we're going to have to rely on our quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. So substituting in the values of a, b, and c, we're going to end up with negative 7 plus or minus 7 squared minus 4 times a times c. And all of this gets divided by 2 times 2. And this here, when we plug this into the calculator, that equals to total 97. So the square root of 97 and divided by 4. So there are your other two zeros. So your zeros here are the following. X equals positive 1/2, again the rational one, and then we have these two irrational ones. We have negative 7 plus the square root of 97 divided by 4, and negative 7 minus the square root of 97 divided by 4. So there's 3 of them. And according to the fundamental theorem of algebra, that matches up because there's 3. This is a degree 3. There has to be 3, or at least 1, but for sure 3 zeros. And we have all 3 of them. So there is your answer. Now, on number 16, we move now on to logs, and we want to evaluate this log. Well, we can't evaluate this unless we use the change of base formula. The change of base formula states that we have the log of a base of some value, we'll call it x. That's going to equal to either the common log, I'm going to stick to the natural log of x over the natural log of b. Or you can use, like I said, the common log of x over the common log of b. So for this example, I can evaluate this because there's no power or factor of 3 that gives me 10. 3 times 2 gives me 9, and 3 times 3 gives me 27. So this value is going to be some irrational number. So the way we're going to solve this is by taking the natural log of 10 and dividing it by the natural log of 3. And now I can actually plug this into the calculator. These keys, again, are on my calculator, and plugging this in, we get the value of 2.096. So there's your answer. All right. Let's go to our final page. For number 17, we need to expand the logarithm completely. So we're going to apply first the product rule, or the product property, that if I am multiplying these two quantities, I could expand this by giving the x its own log and the y its own log, and add those two logs together. Now the power property of expanding simply pulls these exponents to the front and multiplies the log of x by 2 and the log of y by its respective exponent. So our answer is this: 2 times the log of x plus 5 times the log of y. And there's your answer. Now, to solve exponential equations, we're going to just simply use, again, natural logs to do this. So we'll start by subtracting 9 to both sides, and that would be 6. Taking the natural log to the left and the right side of this equation, we end up with that. And using the same property from the last example, we're going to pull this x to the front. So x times the natural log of 4 equals the natural log of 6. And to solve this, we're going to divide by the natural log of 4. That reduces these two to 1, and x is isolated, and we know what the value of x is. X equals the natural log of 6 divided by the natural log of 4. So this is your solution. And on this one, we're not going to estimate a value or plug this into the calculator. We're going to write it like that. And the same thing with the next one on number 19. This equation is going to be solved by, again, rewriting this as an exponential equation. Remember that if we have the log base b of x and it's equal to a value of y, that means that b to the y power is equal to x. So using this property, we're going to write an equation by that. Now the thing we need to know is what the base is on here. On the natural log, our base is e. So therefore, that means that's 2 to the x equals e to the third power. And solving the equation from x from here is simple. Since I'm multiplying by 2, I divide by 2. So x equals e to the third divided by 2. Now moving on to our trig. To convert an angle from 2 degrees, here we have the radian measurement of an angle, and we want to convert it to degrees. We simply multiply by our converter of 180 over pi. That reduces the pi's to a 1, and multiplying across is 1800 divided by 9, which when we divide that, that's a total of 200. So 200 degrees. So theta equals 200 degrees. For number 21, we want to find the cosecant of theta. Remember, the cosecant is the inverse of sine. And since sine on right triangle trigonometry is defined as the opposite side of the of the angle divided by the hypotenuse of the triangle, the cosecant divides the hypotenuse of the right triangle by the opposite side of the angle. And since we have, again, here's our angle, this is the opposite side, and here's my 90-degree angle, and this is the hypotenuse. And while we do not need the adjacent side, I'm just going to label it there. So our answer here is that the cosecant of this angle will simply be 13, that's the hypotenuse, over the opposite side of 5. If I needed the adjacent side, if I needed this side, I would have to use the Pythagorean theorem in order to find that side, which again is just x squared plus, or a squared plus b squared is equal to c squared. So a squared plus b squared equals c squared, where a would be the adjacent side, b would be the opposite side, and c would be the hypotenuse. So a squared plus 5 squared, which is 25, equals 13 squared, which is 169. a squared. We would subtract the 25 from both sides, giving us 144, and then taking the square root, we would get 12. So the adjacent side would be 12. But again, none of this work was necessary. We didn't have to do any of this because we don't need to know what the adjacent side is. If I was doing cosine or tangent, then I would need to know what that adjacent side is. So let's move on. Now, to find the angle on a right triangle, again, using our trigonometry, we see that we're given, again, our angle being down here. We are given the opposite side and the adjacent side. So we would have to use tangents because the tangent equals to the ratio of the opposite over the adjacent. So using the tangent, that trig function, we would get 16 over 13.9. And since the tangent of theta is equal to this, taking the arctan to both sides means that theta equals the arctangent of 16 over 13.9. And that is your answer. We're not going to estimate this, and we're just going to simply write that. And now to number 23. Here, we're looking for we're going to use the given point on the terminal side of this angle theta. So this red right here, that's our theta. And we want to figure out the secant of theta. Well, secant is the reciprocal of cosine. And since cosine of our angle would be x over r, secant would be the reciprocal of that, so r over x. Well, we know what the x value is. We can clearly, again, from the point that's given us, we know that x equals 3. What we do not know is what the value of y is. So the way we're going to figure this out is by using, again, our little Pythagorean theorem, but with the variables of x, y, and r. So replacing x with 3, replacing the y with -4, that's going to equal to r squared. So 9 plus 16 equals r squared, which adds up to 25. Taking the square root, we get that r is equal to 5. So now that we know that r is 5, we can now figure out the secant. So the secant of this angle theta is this value of r over the x coordinate. So your answer is 5 over 3. And finally, for the last problem. For the last problem, we want to figure out the length from B to C. So we want to know how long is this side here. So we're going to call that x. Well, here you'll notice again that we're giving an angle, side, and angle. ASA. So we're going to use the law of sines in order to figure out this missing side right here. So from the law of sines, the side opposite of angle A, so getting A over the sine of angle A equals to getting the opposite side B of the sine of that angle B, which is equal to getting side C and dividing it by the sine of angle C. And A, B, and C again are opposites of the angle. So here we're looking essentially for, let me not call it X, let me call it A. This side over here is C, little c, and this side over here is little b. So we're going to use these two here to set up our proportion. And we don't need this part right there. So if I get A, which we do not know, and divide it by the sine of 98, that's going to equal to getting side B, which is 20 kilometers, and dividing it by the sine of this angle here. Well, it's not labeled, but I know what it equals to because the inside of a triangle has to add up to 180 degrees. So if I get 180, take away the 98 and the 37, that's going to help me figure out the remaining angle to get this total, which that is a total of 45. So this angle here is a 45-degree angle. So taking 20 and dividing by the sine of 45, it is going to be our proportion. And well, to solve this proportion simply requires us to cross multiply. So A equals 20 times the sine of 98 divided by the sine of 45. And we're going to get a total of 28. Now make sure again that your calculator is set to degrees for this problem right here. Verify that the mode on your calculator, let me check here, it again is in degrees, as you see right here. Again up here, it's set in degrees. And like I said, when I cross multiply and I multiply 20 times the sine of 98 and I divide that answer by the sine of 45, that equals to 28.001, but we're just going to estimate it to the first decimal point, so 28.0. And there you go. That concludes the review. If you have any questions, please send me a message on Remind. If there's any errors in submitting or you have trouble submitting your answers on Elastic, please send me a message on Remind or through email. Like always, I appreciate you watching, and I hope you have a great day. Goodbye.